Okay, this is quiz 31. So we're going to draw a logic circuit for each of these truth tables. So the first thing we do is we go through and label what all of these, what F is. So F is going to be A bar, B bar, C. And then this one would be A bar, B, C, A, B bar, C bar, A, B bar, C, A, B, C bar, A, B, C. All right, so F is equal to A bar, B bar, C plus A bar, B, C plus A, B bar, C bar plus A, B bar, C plus A, B, C bar plus A, B, C. Okay, so it'd be nice if we could simplify this. So we notice that, let's see, so what can we notice here? Let's see, first of all, did I do everything right? A bar, B bar, C, A, B, okay. All right, so, so we're going to notice, let's see, can we group things together? So we know that any two things together, like A or A bar is going to be 1. So we notice these two guys, they have a common element, A bar and C, and then that's B bar plus B. And B bar and B are going to be 1, so that's going to give us A bar C. And let's see, this one has the same sort of thing, right? So A, B bar, we can pull out C bar or C, and C bar or C is 1, so it's going to give us an A, B bar. And then here we can pull a factor out A, B, and that's going to give us a C bar or C. And so C bar or C is 1. And so this will be A, B. A, B ANDed with 1, of course, is 1. Okay, and then we notice again here we can factor out an A. So this will be an A bar C plus A, B bar or B, and that's going to be 1. So this is A bar C or A. And then you remember, so on one of our slides, slide 46, we saw that in fact something like this is just simply is the same thing as A or C. So this guy is just, whoops. It's just an OR gate with A and C and F. Okay, so there's our logic circuit. That was a lot of writing. I'll try to write smaller. Okay, so this truth table, again, this is A bar B C. Here we have A B bar C and A B C bar. So F is going to be A bar B C or A B bar C or A B C bar. And the only simplification we can see here is, we can write this as A bar B C or A and B bar C or B C bar. And notice that this is an XOR gate. So this would be A bar B C or A, and then we have B X or B X or C. Oh, yeah, I suppose we could also do something that's interesting back here. Notice we could have done an XOR on these two, and notice when I that X or X is equal to X, so I could have just added an OR here where I'm going to add A, B bar, C. So I'm going to, just XOR with OR X is X. So I still have here an A, B bar, C. So A, B bar, C. And notice that these two now can combine into an A, X or B, C plus A, B, X or C. All right, so I can then take, there's A and B are XORed together, and then I'm going to AND those with C, and then I want to have B and C XORed, so I would have B B and C XORed, and then I'm going to AND that with A, and then I'm going to take those two together, and I'm going to OR those together, and that'll give me F. All right, so there is that logic gate implemented. Down here, we're going to have not A, not B, but C, and then A, not B, not C, and A, B, C. So F then is equal to not A, not B, C, or A, not B, not C, or A, B, C. And let's see, what can we do here? So we could play the same sort of trick here. Well, let's see. So this guy is going to be A, B, not B, not B, not C, or B, C, like that. And then I could have done the same thing. Let's see, A bar C, A C bar. Okay, so I could have combined those two. So if I go ahead and add another one of these, A B bar C bar, A B bar C bar. Remember, I can add in, another or in another one, and it X or X still gives me X. So now I can combine those two to give me. So notice here we've got. When I pull out a B bar, so I'm going to have a B bar, then I'm going to have A bar C and A C bar. So that's A X or C. Okay, so all right, so I guess I could implement this. I have A, B, and C, going in, I take A and C, and I XOR those together, and then I'm going to AND that with B, but I'll not B. Okay, that's that term. And then we're going to have A bar and with C bar. Let's see, so all right, so we have an AND gate here with B and C, and then I'm gonna OR those together with, and then I have to have an AND gate that has B and C. I'm going to OR those together, and I'm going to AND it. I'm sorry, this term isn't there anymore because I've combined those. This term isn't there anymore because I've combined those two terms. So that term is gone. I'm going to OR those two together, and I'm going to AND it with A. And then I've got to OR those two together. I don't know, there's probably something more clever here. All right, so there's a circuit that would implement that.